Okay, we are back for the third session of 4 of them, and we are now going to work with the Physical Sciences Memorandum. But as I said this morning, the Technical Sciences learners must now also blend in with this part of the broadcast of today so that you can pick up on the overlapping questions with Physical Sciences. To the Physical Sciences learners, same message as this morning. You haven't done very well in this control test. And the solution is not to cry about the low marks that many of you have achieved, but to rather iron out the errors that you have made. Because this paper was, like the Technical Sciences, was set to identify errors as mentioned in the diagnostic report of last year's November examination. So if you haven't been successful in the control test, it means you still make the same errors. And we have to help you to iron out those errors for the test that comes up in June, which will actually be an examination, and then September examination, and then the end of the year examination. So it is much better to make the mistakes now and iron out the problems and then do very well at the end of the year, because that is what we want you to do, very well at the end of the year. Okay, I'm going to start with the multiple choice questions. Now, there's quite a number of very important parts of this question paper that I want to deal with in detail. So where I can, I'm going to skip a bit of time, and you will then have to look at the memorandum for those answers. First thing is, the papers and the memoranda will be published on our Free State Physical Science website in a day or 3. So it will be available for you to look through at the end. And there's another document that I also want to look at some stage. Okay, so let's go to question number 1.1. Now, this is purely a multiple choice question based on the definition, so I'm not going to deal with that a lot. You can go yourself, but they talk about it as the product of mass and velocity, which is obviously momentum. So therefore, your answer is C. Question 1.2 is a question similar to the one that we have already discussed in the video for the technical science learners, as well as the test for the physical science test of this morning that we have discussed for technical sciences. But I have also spoken about Newton's third law of motion, as I referred to this morning earlier. But for the table and the earth a little bit away from each other, that you have space here to draw your forces. And once again, as I said this morning, when we deal with Newton's third law of motion forces, it is actually helpful if you supply force labels that indicate what is exerting the force on what. And let's start with a book. Now, the earth attracts the book with a gravitational force. So this one, force of earth on book. So if it is B, T for table, and E for earth, I guess you understand. Now, the force of the earth on the book is this one. It points downwards, and the other part of the action-reaction force will then be the force of the book on the earth. So in other words, there is one action-reaction force pair. Now, this one is also known as weight. Righto? The weight of the book, or the gravitational force of the earth on the book. Now, let's do the same for the table. The earth attracts the table, so it is the force of the earth on the table, and the other part of the action-reaction force is then the force of the table on earth. Now, you can see every time the label switches places, E on T, T on E, E on B, B on E. That is why this is a very handy technique to identify the action-reaction force pairs. Okay, let's go further now. The book pushes against the table in a downward direction, and that is because of the weight of the book. So if the book pushes against the table, then there must be a force of the book on the table. But simultaneously, there must be a force of the table on the book in an upward direction, which will then be this one. And that is your third set of action-reaction force pairs. The same thing happens with the table on the earth, or the floor, or the ground, whatever. The table pushes against the earth. So here it is, table on earth, and because of that, the earth pushes back on the table, and there it is, force of Earth on table. Now, if everything is stationary, with reference to these three objects, then it means these two forces must be equal in magnitude and opposite in direction. But these two are not action-reaction force pairs, because both of them are exerted on the book, one by the table and one by the Earth. The same here. Both of the forces are exerted on the table. So these two are not action-reaction force pairs. In fact, there's a third one here. These two together must be equal in magnitude but opposite in direction to this one here. And then on the Earth we have the same scenario. So your action-reaction force pairs can be identified by labels where they switch places. Now, with that in mind, you can look here, the book on the table and the book on the Earth, the book on the table and the Earth on the book. And you see it's on table, on book, on Earth, on book, on Earth. So let's check the first part. Earth on book, book on Earth. Table on book, table on Earth. Can you see the sequence is not a switch? There is no switch. Book on table, book on Earth. The labels don't switch places. The nouns. Book on table, Earth on book. Earth on book, book on Earth. That looks like a fine one. Earth on the book. So it is this one. Earth on the book is that one. And book on, Earth on book and book on Earth. So here it is. So number C should be your answer. Let us just look at the others. Book on table. Book on table. In other words, book on table. This one's action-reaction force pair is the table on the book, but this one says book on Earth, so it's incorrect. Book on table, it's still this one. Book on table is that one. Its friend as action-reaction force pair is table on book, but this option B says Earth on book, so B is incorrect. C we have covered. Look at this one, table on book, so it is the table on the book. Table on the book is this one. Table on the book. Its action force pair is obviously book on table, but here it says table on Earth. So I hope with this little sketch, and you can look at the video again and again, I hope it helps you to be more successful with action-reaction force pairs. And remember, as I said this morning, this is nice labeling when you deal with Newton's third law of motion and action-reaction force pairs. However, when you deal with calculations, use the ordinary symbols like W and the N and the F, etc., etc. So your answer is C. By the way, I promised this morning when I do something that is applicable on physical sciences, but in the technical science paper I will indicate that, and vice versa. So now I have to indicate what is applicable on technical sciences. So this one is applicable on technical sciences, and that one is applicable on technical sciences. Number 3, or 1.3, this one is also applicable on technical sciences. Now, they had a similar question in their question paper. Let's look at this one. A force F is applied to push a block across a rough immediately. Rough means there's a force of friction. Here it sits. Horizontal, okay, fine, at a constant speed. What does constant speed mean? As we said this morning, constant speed means your acceleration is 0. It doesn't go faster, it doesn't go slower, and it doesn't change direction at a certain speed v. The force diagram below shows the forces acting on the block whilst moving across the surface. Which one of the following represents the correct relationship between the magnitudes of the given forces? In other words, we must analyze these ones. So let's quickly look at this specific one. As I indicated this morning, if you have a force F, there's your force F that is basically at an angle, then you have two components. We've done this a lot of times during today's memo discussions. So this one will be the vertical component of F, and sorry, there's no space here, but I'm going to put it here. The horizontal component of F is horizontally to the right, and vertical component of F is downwards. We have weight, we have the normal force, the direction of motion is in this direction, and remember it is at constant speed or velocity. In other words, acceleration is 0. So let's analyze what must happen between these forces so that this can happen. To move at constant speed, it means all the forces in the horizontal direction must have a net force of 0. And there are only two of them, namely the horizontal component of F and the frictional force. So the horizontal component of F and friction must be the same in terms of magnitude. Now, do we have such a case? Well, here we have F equals to F, which is not correct. We look for the horizontal component of F. F and so on and so forth. So it seems to me they don't have any horizontal component of F involved here. However, what they have is F. Now, if you look at this triangle, remember the green one is the resultant of these two red ones. Therefore, this one must be larger than these two. So F is greater than F horizontal. Therefore, F must be greater than friction in order to move to the right. But it moves at constant speed. If it moves at constant speed, F and FH must be the same, so F must be greater than F to achieve the constant speed scenario. So F greater than F seems fine, so that one seems fine, and this one seems fine. F equals to F cannot be, so we are happy with that. Okay, now they compare the normal force and the weight, but what you mustn't forget now is that weight is downwards and the vertical component is downwards. So in terms of magnitude, the vertical component of weight the vertical component of F plus weight must be equal to the normal force. If I have already changed the directions in the correct way. So what is the relationship between the normal force and weight? If you struggle with this type of thing, just put in numbers for yourself that you can check. Because if you have the normal force and weight, they can't be equal in magnitude because weight plus this is equal to the normal force. So this one is wrong. And then that one must also be wrong. So now we must check between n greater than W and n smaller than W. Okay, let's put in numbers. Let's say this is 10, this is 12, then this is 22. Okay, so the normal force compared to the weight, the normal force must be more than the weight. Why? Because with weight, there's a vertical force pointing down. So if the vertical force of F or the vertical component of F was not there, these two would have been equal. But now you add a third force downwards, the component of F, and therefore N becomes greater, but W remains the same. So the normal force is more than the weight. So the normal force is less than the weight. This is wrong, and normal force is greater than weight. That's correct. So therefore your answer should be C. Quite complicated to work out, but once you've seen that, I guess it will be not so difficult. Okay, 1.4. This was tested twice in the question paper. No, it's not this one, it's the next one. This one is also just a basic formula or a definition. Which one of the following statements is equivalent, in other words, more or less the same as Newton's second law of motion? Now, the answer is A. You can look through it yourself. The rate of change in momentum of that object. Remember, the rate of change is, this must be delta T. Is equal to delta P. So if you divide by delta T, you get F net is delta P over delta T. So the net force is equivalent to the rate of change of momentum. Okay, number 1.5. This one and 1.7, these two questions tested the same thing in this question paper to see if you understand very well. What is the magnitude and direction of the acceleration on Earth at the turning point for an object that is thrown vertically upwards from the surface of Earth if resistance is ignored? Let us just explore this a little bit. Let's say this is Earth and you project something upwards. Now I'm going to make it a little bit more realistic, because many people don't understand this thing. So instead of throwing the object upwards, I'm going to imagine that I have something like a hole in the ground, and in the hole, and I'm now going to enlarge it a little bit. So in the hole, I have a piston, and this piston has that's a piston more or less, and let's say this piston has a lot of wires around it in the form of a spring, a steel spring, and there's a little, to make it technically correct, let's put another small hole here, and now you take this piston and you put it here, and you push it down so that it sits there, so it sits there, and the spring is now compressed. Now I take, let's say, a marble or something, and I put it on top of this piston, and you have designed the piston and the spring such that when the piston stop, this part reaches the top of the ground, in other words, the level with the ground, at that point, the spring has become relaxed. In other words, it doesn't push anymore. So that means from there to there, there's a force on the marble upwards because of the piston, and obviously the marble experiences a weight. But the spring pushes up, so that force is much greater than the weight. And if this one is greater than this one, there must be an upward acceleration, which is determined by the combination of these two. The acceleration associated with weight is 9.8 meters per second squared. But if there are other forces acting on the marble, then this is not valid by itself. The combination of these two determine your acceleration. So if this one is 20 and that one is, for example, 50, then the net force upwards is 50 minus 20 divided by the mass, and that will be your acceleration. So this thing picks up speed as it goes this way. And now I'm going to say something extremely important. If your velocity, physical science learners, listen to this. If your velocity and your acceleration are the same, the velocity increases. All right, it increases. So by the time the marble reaches this point, let's call it point X, it has its maximum velocity, because at that point, the spring is relaxed, so it doesn't push against the marble. So while it is in the hole, this is the situation. Once the piston's top is in line with the ground, what is the scenario? Only this. We assume there is no air resistance. In other words, when it doesn't push upwards anymore, this force F disappears, and the only force acting on the marble is W. In other words, the acceleration associated with W is now downwards. In other words, it accelerates downwards, but it is still moving upwards because it has had a sort of a speed there, and from that point onwards it goes slower, and then it stops somewhere here. All right, so somewhere there it stops. Now here is the next very important thing. If the direction of velocity and the direction of acceleration are opposite, this one decreases. In other words, and this is your experience, it goes slower until it stops. Now it comes back, but if there's no air resistance, then in coming back, this force is the only force on the object. It's still the only force on the object, but then velocity is downwards, and the acceleration, which is actually gravitational acceleration, is still downwards. Now they are again in the same direction. Therefore, this velocity increases again. And this is your experience. When you throw something upwards, the moment it leaves your hand, it represents this point. In other words, this part here is just a technique to get it going. But from that point, it is in free fall. It becomes a projectile if that is the only force acting on it and you have given it an initial velocity. So it moves up, stops, comes down, faster, faster, faster. So slower up, faster down. And remember this part. I just explained this part because many people don't know that during that period when you project the thing upwards, weight is not the only force acting on it, and it is not part of the free fall part of the object. Free fall is only in this part. This has another set of physics involved. Okay, so now, what is the scenario? The acceleration will be 9,8 downwards while it is going up as well as down. On top, the velocity will be 0 at that turning point. Going up, velocity decreases, speed, you can say speed decreases, velocity increases, but they move in straight lines in any case. Now the big thing, what about acceleration at the top? Now what happens at the top? Remember, the Earth is still here, and the Earth still pulls on the marble. So there's still a gravitational force on the marble. At the top, weight is still applicable. The marble still has weight. Therefore, there's still acceleration, and this acceleration is still 9,8 meters per second squared downwards if you are near the surface of Earth. So the acceleration remains the same right through, 9,8 meters per second squared downwards. Velocity is up, goes slower, becomes 0, increases downwards. Now they ask, what is the magnitude and direction of the acceleration on Earth? The magnitude obviously is 9,8. And what is the direction? Downwards and downwards. So your answer is B, 1.5B. Now on this, let's jump quickly to number C, or actually 1.7. An object is thrown vertically upwards. Which combination of physical quantities have non-zero values? At the instant, remember, at that instant, it is just for a moment that it sits there still, that it sits still there and then comes back. At the instant when the object changes direction. Now let's look at these things. Well, if I move this a little bit to the left, Bobby, I think we will still be fine like that. Yes. And hopefully we can see that as well. Yeah, Bobby, welcome back. Bobby told me during break that he likes the physical sciences. Bobby, I like it that you are here. Thanks for this. Okay, so let's look at 1.7. Non-zero values. Now momentum, at the instant the object changes velocity or the direction. Remember when it changes direction, at that moment the velocity is 0. Now momentum is mass times velocity. So this guy is going to be 0. What about the weight? Well, whether it moves or not, the weight is not 0. So this one is not 0. So this one is not 0. There's a weight. It's not 0. Let's look at acceleration. I've just explained. Acceleration remains 9,8. You see, and this is the catch here. Acceleration, although it is stationary, the acceleration value remains 9,8 downwards. So acceleration at that point is not 0, so not 0, not 0. What about momentum? We had momentum here. At the instant where it changes direction, momentum is 0. And then here, momentum is 0. Now there I have also given you an sort of a way to look at how you answer a multiple choice question. So you have to select the combination with non-zero values. There's a 0, non-zero, non-zero, non-zero. It looks like that is our answer. Not 0, 0, not 0, not 0, 0. So that is the only one with non-zero answers for both of them. So keep this in mind because it is an old problem in physical sciences for many learners. They think the acceleration is 0 at that point where the object stops, in other words, the highest point. Now just think about that. If acceleration becomes 0 at that point, then the object can't move anywhere else. It can't go up, it can't go down, etc. So acceleration is not 0 at the highest point. Velocity is 0 at the highest point. I hope you are comfortable with that so that you never make that mistake again. 1.6, a ball is released from rest from rest. In other words, the initial velocity is 0. At a certain height above the ground, which one of the following momentum versus time graphs correctly describes the momentum of the ball from the instant it is released, in other words, when initial velocity is 0, to the instant just before it hits the ground, in other words, the greatest velocity, and take downward as positive. This is quite important when you ask graphs. And I forgot again about the technical science learners. You can leave this one. This one is not for technical sciences, and number 1.7 is also not for technical sciences. My apologies, I forgot to mention that, because this deals with vertical motion, which you don't have in your curriculum. Okay, let's go back to 1.6. I would say 1.6, yeah, maybe. It's challenging whenever we have graph questions. It's quite challenging, but if the technical science learners find it interesting, they can come with us, because it's actually, no, let's rather say it's not for you, although you have to know graphs, but in a way, yes, so it's in between. Let me explain, and then you will be able to see what I mean. Right, at the beginning of grade 11, you have done a part on graphs, direct proportionalities, you know, straight line graphs and stuff like that, so I guess you will be able to do this one. Now, the problem with graphs is you must be able to connect the correct mathematics with a graph. And the way I always felt, one way to do that is the following. Start by thinking, I mean, all these graphs are P versus T. So start by thinking about the formula for momentum. It's one way to do that. Right, P is equal to M times V. Now, the part that's problematic for technical science learners is the equation now. So let's think about a velocity. Let's say you travel for 1 hour and you cover 100 kilometers. Then it means your average velocity is 100 kilometers per hour. If you travel another hour and you travel for another 100 kilometers, your average velocity is another 100 kilometers per hour. So can you see, in terms of traveling and velocity, if you double the time and you travel at the same speed, you double the distance. But if you travel faster in the same time, you will have an increasing velocity. And this is part of the thinking here. Now, for the physical science learners, if you want to relate the V with T, because we must get P to T, we can use this equation. We can say, well, we have an equation that says the final velocity every time is initial velocity plus A times delta T. Now remember, the initial velocity was 0. So 0 times M will give me 0. And the other one will then be M multiplied by A multiplied by delta T. Now the mass of the object remains the same, obviously. The acceleration remains the same. So this part is a constant. In other words, P can be written as 0 plus a constant multiplied by delta T. Now I'm just going to swap this around and say K delta T plus 0. That is equal to P. And you know there is an equation in mathematics that looks like that. Y is equal to mx plus c, where c is your y-intercept, m is your gradient, and x is your x-axis measurement with y-axis here. So P and Y and M and K and delta T and X. In other words, if I don't have an X on the horizontal axis but the delta T, it looks like these ones, or just T, and then the y-intercept. So the y-intercept for my P equation is 0. So that part is correct, this part is incorrect, that part is correct, and this part is correct. But what now? It looks like a straight line graph. So the answer must be this one. It must be this one because the y-intercept is 0, and if I double the time, I double my momentum. This one cannot, because this looked like a parabola, and this one looks like a hyperbola. And this one, although it's a straight line, it means the initial velocity or the initial momentum was negative something. And they said you release it from 0. Now, if you release it from 0, then the momentum must be 0. And for example, if this was -7, then it can't tally up there. So your answer is A. So technical science learners, you can think a little bit with this here because you have done graphs. The tricky part for you is how do you take V to T, but with my explanation of V doubles when T doubles, okay, that means the more time, the more velocity, the more momentum, and there's no exponents involved, so it must be a straight line, and based on that you could have chosen either this one or that one, and with initial velocity 0 and momentum 0, you have maybe taken that one. I would guess that would be the answer. Okay, then 1.7 is finished. Now we go to organic chemistry. Now for the technical science learners, in term 2, you are going to do organic chemistry. So you can come back later. The majority of the questions in this question paper is good exercise for you once you have done organic chemistry. But for now, you can sit back and relax a little bit until I reach question number 2. Right. Study the following pairs of organic structures. Now, to save time, I have drawn them for you here on the question paper just for the sake of time so that we don't neglect the physical science learners. We barely finished the technical science paper, so I don't want to miss out on a part of physical science. If need be, we leave out the easy parts. Right. Now, they want to know the following. They say, study the following pairs of organic structures, and there are 3 pairs or 6 of them. Which of the above are structural isomers? Now, your first stop is this. What is a structural isomer? And the definition is in your examination guideline. They are on the website. We couldn't print them for you this year, but download them. Those of you can put them on your cell phones. Get them, ask your teacher where it is. If they don't know, let them ask the subject advisors. You must have that document, the examinable content document for learners. You must have it, physical science learners. There's a document for teachers and the same document for learners. In the case of the learners, all the definitions are there. The teacher document differs from the learner document in that it deals with some formalities regarding examinations and stuff. The learner document has all the definitions, what is expected from you, with some explanations and so on. In the case of technical sciences, nobody has ever written one for learners specifically. So in the case of technical sciences, you just use the teacher document as well. And both of them are on the website with the address of hwscience.blogspot.com. And then you go on the left-hand side, there's a part that talks about pages, and there is a section that says examinations, learners, and teachers. You get it there. So you must have this document in e-format at least. If your school can copy that, wonderful, but you must have it. Okay, what is a structural isomer? It is something with the same molecular formula, but different structures. So they look different. So I've written down the molecular formulae for you on the left-hand side of each of these. Look here. 1, 2, 3 carbons, so it's 3, C3. 3 hydrogens there, 3 hydrogens there, so it's 6 hydrogens and a single oxygen. The same here, 1, 2, 3 carbons, 3, 4, 5, 6 hydrogens and a single oxygen. In other words, these two have the same molecular formula. In other words, that formula where you just number the number of carbons, hydrogens, and oxygens. But what do these two look like? Now, I've drawn the structure for you there. There it is, CH3. And please, learners, I'm not writing examinations. I'm teaching you now, and therefore I need to save time. So I have not put in the H atoms here. When you do that in an examination, you lose marks. So please don't blame me in future for leaving out H's. It is for sake of time saving now. So it's CH3 there, the carbon with the 3 bonds, and each one carries a hydrogen. Then another C, an oxygen. Now between carbon and oxygen, you must have a double bond. And then a CH3 again. Now if you look at this one, the carbon with a double bond is bonded to a carbon there and there. So this is the famous thing called a ketone. A ketone, and you must be able to recognize the ketones. It is where a carbon with a double bond O is connected or bonded to two other carbons. And what is this? There's another carbon connected to a double bond O, or connected to or bonded to a O, one should not say connected, bonded to oxygen with a double bond, but on this side you have a hydrogen. So this is an aldehyde. For the Afrikaans-speaking learners, we talk about this one as ketone, and we can spell it the same in terms of plural. Ons spel dit dieselfde as dit 'n meervoud is. Enkelvoud sê ons ketoon. Ketone, meervoud, ketoon. Aldehyde, en ons spel dit net H-I-E-D. Right. Now, in other words, these two are structural isomers. They have different structures, but the same molecular formula. Let's look at this one. 1, 2, 3, 4, 1, 2, 3, 4, H's, 2, 3, 4, 5, 6, 7, 8 of them, and the same there. So the molecular formula is the same. What does the structure look like? Right, there it is. CH2, a CH, another CH2, and another CH3. So this CH must have a double bond there, so that there's 4 bonds around this carbon and 4 bonds around that carbon. And this one is CH3, CH, CH, CH3. This is only possible if you have a double bond there. So there's 4 carbons there, 4 bonds, 4 bonds, 4 bonds, and 4 bonds. Both of them have double bonds, the one between these 2 carbons and the other one between those 2 carbons. So the structures differ, molecular formula the same, so these two are structural isomers. And what about the last one? It's drawn here. So you have 1, 2 carbons, and there you have 1, 2 carbons. Hydrogens, 1, 2, 3, 4, and 2 oxygens. 1, 2, 3, 4, and 2 oxygens. Molecular formula the same, and the structures differ. By the way, these ones are alkenes. Ne? I haven't written it here. It's alkenes. In the case of this one, the double bond sits between carbon 1 and 2, and in this case, it sits between carbons 2 and 3. So it's a same functional group, but the double bond sits at a different place. There you have different functional groups. You have the ketones here, and you have the aldehydes there. What about this one? Now let's look. Carbon, double bond O, and a OCOO, and there you have a C double bond O and a OH. So this one is quite familiar. This is the carboxylic acids, the carboxylic acid. And in this case, we have COC with a double bond O. So this one is the same as that one, because with your carbon double bond O and a H here, you have an aldehyde again. All right, now with that, I guess it's enough info for you to be able to answer the question. Molecular formula the same, but different structures, a carboxylic acid and an aldehyde. And therefore, these two are also structural isomers. So 1, 2, and 3 are structural isomers. So I hope that has helped you to answer this one. 1.9. What is the empirical formula? As I said this morning to the technical science learners, when something is written in capital letters, you must be careful because there's a reason for that. The empirical formula, now first of all, what is an empirical formula? It is when you write down the molecular formula in its most simple form. In other words, smallest whole numbers for the number of carbons, hydrogens, etc. Of ethyl ethanoate. The Afrikaans word for this is ethyl ethanoate. Ethyl ethanoate. Okay. Now I've written it here. Organic chemistry is a strange part of chemistry in the sense that some people see the answers immediately. Others have to work through it. Either way, it's quite easy to come up with the answer. And the way I would suggest, if you can't see the answer immediately, because sometimes people can memorize the general formulae and the number of isomers, there are formulae to give you that. If you don't know that by heart, then just work through the thing and get the answer because it's quite easy. Okay, first and foremost, ethyl ethanoate is an ester. Those things that smell so lovely. And they are produced from alcohols and carboxylic acids. Now, if you have ethyl, then it must come from ethanol, and in Afrikaans we say ethanol. And that is the structural formula of ethanol. 2 carbons and an OH, a hydroxyl group, a hydroxyl group, connected or bonded to a carbon. Right. Ethanoate, it comes from ethanoic acid, etanoesuur. So it is almost like the alcohol, but on this carbon where the OH is, there's a double bond O. So there you have ethanoic acid. Now these two bond with each other. And one of the hydrogens disappear, and you must go and check which one. Is it the hydrogen from there or from there? And the OH group of one of them disappear, and now you must also make sure that you know which one it is. Nevertheless, when the OH and the H are gone, they bond and form water, and the remaining parts connect again and they form this. So here you have the CH3, the C double bond O, and you have an oxygen, and then you have CH2 and CH3. And that one is ethyl ethanoate, or in Afrikaans ethyl ethanoate. Now if I write down the molecular formula, I get 1, 2, 3, 4. There's 2 oxygens, okay, that's easy. Hydrogens, 2, 4, 5, 6, 7, 8. So there are 8 hydrogens and 2 oxygens. Let us just make sure. 1, 2, 3, 4. That's correct. 1, 2, 3, 4, 5, 6, 7, 8. Yes. And 2 oxygens. That is the molecular formula. But you can see the ratio is 4 to 8 to 2. So one can make that smaller by dividing by 2 right through. So 4 divided by 2 give you 2. 8 divided by 2 give you 4. And 2 divided by 2 give you 1. So the empirical formula is C2H4O, C2H4O, so that must be your answer. The majority of learners picked this one, C4H8O2. That is ethyl ethanoate's molecular formula, but they asked the empirical formula. So that was basically quite easy to do that. And if you haven't calculated this one or answered this one correctly, you've really wasted 2 marks, because it is all about concentration and answer what they want to have. So I hope this shows you that the question paper was certainly not unreasonable. This question paper is a well-balanced question paper with enormous opportunities of identifying errors. And if you cut out all these errors, I promise you, you will get good marks. This is also true for this question. The structural formula of an organic compound is shown below. Now, I thought of working on the question paper. You might find it a little bit difficult. I'll keep an eye on the image on this side. And if you find it difficult, we can change to another paper where it is a little bit bigger. Right. There's your organic structure, and they want to know the correct IOPAC name. Now, learners, there's something very important here. I hope you have this document. Let me just jump there. If you do not have this document, as far as I know, this document is not translated. We can work on that. But the Afrikaans-speaking learners can also use this document to great effect, because you have your notes in school. Unfortunately, it's quite hard to translate everything. You should actually get your translated documents, but bear with us if we can't always supply everything translated. But look at what it looks like. The document looks like this. There's the whole page. Physical Sciences Organic Molecules. This is the best resource that you can have for your organic studies. Nomenclature is there, how you name them, etc., etc. If you do not have this document, you must get it. It is better than any textbook on the market. It was written by colleagues here in the Free State, and I will put this document in the cloud for you, and I will send that address to your teachers. So ask your teacher for the cloud address when you return to school on Monday if you do not have this document. It will not be on the website. The website doesn't have enough space for all the documents. That's why I put it in a separate web space. And I will put it there for you, and you download it, Afrikaans and English, and go through that, because all the rules for IOPAC is there. A lot of exceptionally good information. So it's important that you get this document. Take a look again what it looks like. It has this blue band on top, and it says Physical Science Organic Molecules Learner Revision Guide Grade 12. Okay, so let's jump back to this one. Correct IOPAC name. Okay, first and foremost, we choose the longest chain. So, okay, let's see. If I scan through this thing, I see there's a main chain, and then substitute groups from the sides, etc. There is something interesting. There's a halogen. Fluorine sits there. So I can now number maybe from this side. Let's start from this side. Let's say this is carbon number 1, carbon number 2. That one will then be carbon number 3. If I go up, it's 4, 5. If I go to the right, it's 4, 5. If I go to the right and down, it's 4, 5. Or to the right and up, it's 4, 5. So doesn't matter what I do, the longest carbon chain is 5. If that is my longest chain, then I know this is a type of alkene, because between all these carbons are single bonds. Then I sit with something there, and this is called a methyl. And I sit with something there, and this is called a methyl. So I have 2 methyls on carbon number 4. In Afrikaans, 2 methylen op koolstof 4 en 'n fluor op koolstof 2. En op koolstof 3 het ek ethyl. So ethyl on carbon 3. Now let's summarize this. I have fluorine on carbon 2. I have 4 and 4, and this is methyl. I just want to write down something. And on carbon number 3, I have ethyl. Now this combination of numbers gives me a total of 8, and 5 is 13. If I number from the other side, and I will do that for you in blue. Let's say we make this carbon 1, 2, 3, 4, and 5. What is the case now? Now, my fluorine sits on carbon 4. My ethyl still sits on carbon 3, so it's not going to make a difference there. But the 2 methyls are sitting on carbon 2 and carbon 2. And this combination of numbers give me 11. So 4 and 4 is 8, 9, 10, 11. The lowest combination of numbers, in other words, is this one. So the pencil numbers are not going to be used. That is the catch in this question. We cannot use the pencil numbers. Once that is now established, then I can use these numbers to make up my name, and when I use fluorine, methyl, and ethyl, I will put them in alphabetical order. Now, E is before F, and F is before M. So I must start with ethyl, then fluoro, and then methyl. Okay, now ethyl sits on carbon 3. So let's look. 3 ethyl, 3 ethyl. So it might be either B or D. Né? Then the next one must be fluoro. Now fluoro must sit on carbon 4. And there it is, and not carbon 2. And if you are there, you have already identified your answer to be B. And the methyl must be on carbon number 2 and 2. Once you've done that, now you can write down the whole name. The basic chain is 5 carbons with single bonds, so it's pentane, pen for 5, ane, pentane. And on the sides, I have an ethyl group on carbon 3, a fluorine, a fluoro atom on carbon 4, and 2 methyls, and you know we put that as dimethyl. But the di doesn't count as part of your alphabetical sequence. So never think about a D sitting here. It is either methyl or ethyl. Dimethyl and trimethyl and so on doesn't count. The T for tri and the D for di. It's only methyl and fluoro and ethyl. And there's your name. Now, many people asked us, why is it not number D? Why is it not number D? Now you can see D is the pencil numbers. Né? The ethyl sits on carbon 3, which is fine. Fluoro on 2, and the 2 methyls on carbon 4. Why is it not D? Because of this rule. You must take the lowest combination of numbers. Now there are many of these. We hope to give you some videos on this later on so that you can plan, well, look at them so that you don't have any mistakes. Bobby, we have maybe 10 to 15 minutes, so maybe we can finish question 2. Right, so to all the learners in physical sciences, let me just check here, 1, 2, 3, 4, 5, 6. This question will not be asked for technical sciences. You can have a maximum of, I think, 6 carbons in your structures, so you don't need to worry about this specific one, but you will have similar ones, just maybe a little bit less confusing. Okay. Question number 2. Let's see if we can fix up this one before we break, because I really want to work through the whole question paper. And where possible, I'm just going to show you the memo, but where we have problems, I want to write it out for you. Okay, question number 2. Technical sciences, you don't need to worry about this one. The reason is you don't have pulley problems. That's the first reason why you don't need to worry about this question. And the second reason is your objects must all be on the same level. In this case, it is vertical for the 260 gram and horizontal. So the technical science learners can leave this one. But very interesting. When you see me calculating this thing, you will actually see it's basically the same as your question this morning of that connected object M and N. Right, now without further delay, let us quickly look at this question. Okay, I just want to, sometimes I'm not so stable, so let me use a pencil just to draw that force F in blue there. Let's go through the question. A block M resting, immediately we know, né? Resting means it is at rest. It's standing still, it's stationary, dis in rus. On a rough horizontal table. Rough means we have friction. This thing is connected by a light inextensible string. Inextensible, even if they don't mention that, in grade 12, we don't work with connected objects by elastic bands or so on. Now, if you have an elastic band, then it means when one starts, the other one can still remain a little bit and then follows maybe. But we don't deal with those situations in school physics. At university, you can do that. But inextensible means inelastic. Therefore, when the object starts to move, the one in the front, the one at the back will immediately move, whether it's connected to a pulley or whatever. And in our work, the pulley is also frictionless, and normally we take out friction and so on. Right. The 260 gram, there's the 260 gram. So obviously, this one must become 0.260 kilogram. Ne? We don't work in grams. Okay, so I think everything is covered there. The blue force is 60 Newton. And now before we get there, I thought of mentioning this to you. This is such an interesting question. And I don't want to draw on the sheet now with pen. I just want to show you something. This one here, the 260, if you read the question, a block is resting. In other words, this one is stationary. Now, if this one is stationary, then it means this one is stationary. Now, let's draw the forces on this one. So, I don't want to go into the writing here. So, it is the weight of the 260 gram block. So, the earth on the block, therefore, it pulls down. Therefore, this rope there, the rope must exert the force upwards on the block, equal in magnitude to the W, because it should remain stationary. Now, this type of force, you know by now, we call it a T, because the magnitude of this force of the rope on the block is the same right through the rope. And then on this side, we have T as well on that one. Okay, then on this one, obviously we have weight and we have a normal force. And I'm going to talk a lot about the normal force in a few minutes. This is such amazing physics. I love this and I hope you enjoy this. And if you can sort out your problems, learners, you can do so well towards the end of the year from June onwards. That's why, and I want to repeat it once more, don't cry too much about the marks. It showed that you can't handle some of these situations. Therefore, iron out the mistakes. Believe me, you will reap the benefits. The paper was a good paper to identify your problems. Right, now just on this first paragraph, they talk about the block, resting, blah, blah, blah. This first paragraph doesn't mention this force. And somewhere in the June examination, I think we must develop a question like this to see if you listen what I'm going to say now. This one is resting. Do you agree with me? Nothing in this paragraph is mentioned about the 60 Newton force. So when you read through the 60 Newton force, this one is still not applicable. It only starts here to say a force of 60 Newton is then applied to the stationary block. So just on the physics of this thing, if this block is stationary without this 60 Newton force, do you agree with me there should be a force of friction in this direction? Because to remain stationary with the force, the rope pulling in this direction, there must be a frictional force in this direction. In other words, one could have asked a question to say, what is the magnitude and direction, well, or the direction of the frictional force before the 60 Newton force is applied? And it's to the left, horizontally to the left. But now you come and you apply the 60 Newton force. It's applied to the stationary block on the table at such and such an angle, and it causes this block to accelerate. So it accelerates now in this direction at 2,89 meters per second squared. The moment when you apply this block, the frictional force was responsible to keep it stationary. Now the frictional force to the left flips around and becomes a frictional force to the right. A kinetic frictional force to the right, because it is a rough table, né? And if this block moves in this direction, the force of friction on this block is in that direction. And the force of friction on the table is in this direction, while this force is pulling. So I just wanted to come up with this thing. Without that, the force of friction is in the opposite direction. Okay, let's go quick now. A force of 60 Newton is applied, the table, angle, and so on, acceleration we have. The coefficient of kinetic friction between the block and the surface of the table is 0,3. So this is our kinetic frictional coefficient. Define the term normal force in words. I'm not going to waste time. All I want to say is you have the memo, or you're going to have the memo. These definitions are all in the memo and in your examination guidelines. Don't cry when you don't get full marks for definitions. It means you haven't sat long enough and learned them and memorized them. The teacher cannot memorize on your behalf. BOC, bum on chair, and you have to memorize them. You can get a lot of marks. Go count all these definition and law marks in this paper, as well as technical sciences. You will see it's quite a lot. And if you get all of them, it's your benefit. So there's a challenge for you. Right, calculate the tension in the string. Okay. Now the tension in the string, there's two tensions. There's one, and we know they are equal in magnitude, but we regard them opposite in direction. Yeah, and this is something I must probably just say. A pulley is only something to change direction. In other words, if we had them on the same surface, then tension on the one has the same magnitude as tension on the other one. So the end of the rope on one object exerts a force in the opposite direction as the other end of the rope on the other object. Now we bend them over a pulley. Same scenario. It is just that the pulley helps us to have different dimensions. Okay, so Bobby, is it okay if we go on a little bit? Just a few more minutes, will that be fine? Bobby says it's perfect. All right, so let us check this one. Calculate the tension in the string. Now, if you analyze this thing, let's see. Let's see. For this object, you have, that one is known to you. The friction, is the friction known to you? Not really, although you know the coefficient of friction. But with a coefficient of friction, you need the normal force. And the normal force is not known at this stage. So you can't work directly with this object. What about this object? Do you know the weight? Well, it is mass times gravitational acceleration. And once again, at the end of your paper, you have all these lovely symbols and formulae, etc. Okay, so it seems to me it's easy to calculate the weight. And with this and that, it will then be easy to calculate the tension in the string. Okay, so let's do that. It will now be question 2.2.1. So we start off by saying F net is equal to M times A. This is quite important that you always start with your basic formula, because the moment you do that, if a mark is awarded for a formula, that mark is awarded for you there and then. As I said this morning and a number of times afterwards, write down the components of this net force. Now in this case, it is T plus W equals M times A. So far, I have not yet substituted. I just write down the addition of vectors. Okay, so now I choose a direction. Now if the body, this one is going this direction, because this is what it said here. Let me just get it on screen. It goes to the left, so this one will go upward. You can do it differently, but the direction of acceleration, if you take that as positive, it normally works easy, but you can change it, you can do it otherwise as well. Okay, now we substitute. So T plus, what is weight? It is M times G. Now the M is 0.26 kilogram. Gravitational acceleration. Listen how I talk now. Here's the gold on the water. mg, the G magnitude is 9.8. What is the direction of 9.8? Downwards. It's not positive or negative. It's downwards. I have chosen up as positive, and that's why it should be negative. And there's a subtle difference between saying 9.8 negative or 9.8 downwards. The direction is downwards. So if you choose up as positive, then you supply a negative for that number. That type of thing, it's important to get it right. So therefore, this part, the whole part here, will be negative, indicating that it is downwards, is equal to the mass of this object. What was that now? 0.26, 0.26, and acceleration. Now this one moves upwards, so it's positive, and it will then be 2.89, because remember they told us that it's somewhere here. So if that one accelerates with 2.89, then this one must accelerate with 2.89. Okay, I think I have everything. T plus 0.2, negative, negative, negative. I'm not going to show you the steps. So if you solve it, you get 3.2994 Newton. And please check now. It ends with a positive here. So it shows that the direction of the force exerted by the rope there is upwards. So the direction of the force on this object at that point will be negative, this number. All right, and there's your first one. And I just want to show you how they have awarded marks for this, because this is actually quite easy. Just be careful here. Sometimes the examiners, when they write down the formulae, they already capture the unit. While here, I haven't done that. I have said T plus weight. So this part is still the addition of vectors. And when I have substituted, I bring along my negatives and positives. The only thing they have done is they have taken that positive already in there. So don't become confused by this. I believe this method is more clear because it's actually very correct physics, this, the fact that you show the addition of the components for that vector. Okay, now 2.2.2, we will go 5 more minutes, so let's quickly see if we can fix up this one. 2.2.2, calculate the mass m. Now this is a big shot. Calculate the mass m. Obviously, we have to work with this thing. We have to work with this one. So, what can we do? Let's think a little bit about our scenario here. We will use F net is equal to m times a. Now, the mass of this object is obviously a capital M, and that is what we want. Do we know acceleration? Yes, it's given to us. It's that 2,89. Oh, sorry, I am not on screen. There it is. So F net is m times a. So a we know, it is that 2,89. The mass of the object is what we need to determine, so it is that one. Now, in a horizontal plane, what forces do we have there? Let's just quickly check. We have, and if you bring this in here, we have, let's go that way, we have that force with its components, because remember, as I said before, there's a horizontal component like that, and then a vertical component like that. So, in a vertical plane, we have FH, then we have T, then we have F. This is the components in a horizontal plane, FH, T, and F for body M. And this is equal to m times a. Now the question is, do we have T? Yes, we have calculated it there, so we have it. Do we have the frictional force? We don't. So how do we get the frictional force? We must think about its formula. Do we have the coefficient? Yes, it's given because it is there. Do we have the normal force? Well, not really. So we first have to calculate the normal force, because in the vertical plane we have a normal force, a weight, and a vertical force. So the normal force there will come from the combination of weight, vertical force, these, and these will help you to get those. And remember, this part can be calculated by thinking that F net in the vertical plane is 0, because the body doesn't go into the surface and it doesn't go upwards. Right, so that's the way we think through that one. So once we have done this, we know the normal force, then we know the friction, the T we have, and FH, it's possible to calculate that because we have the force and the thing there. And remember, part of W will be m times G. We know G, and capital M is still there. So there's a capital M which is unknown, and there is a capital M which is unknown. But if it is the same symbol, we will be able to solve that. And this is what I want to suggest to you, that whenever you have a complicated question to solve, go through the thinking process. You have time to do that in the examination. Use your rough work paper and lay out a scheme like I've done here. And that will really help you to solve these things successfully. Bobby, I think we can take a break for 5 minutes. So 14 minutes past 3, we start again so that we can do the whole memo for you. Dankie, Bobby. Bye-bye. Okay, last session. You know, I feel so honored actually to be here to help you, and Bobby helps us, etc. And I hope the learners benefit from this. It's really, really important. And you have all these amazing facilities like IBP and YouTube and stuff like that. Now, talking of YouTube, earlier today I mentioned that the channel on which all these videos are posted is called FS-IBP. Now, for those of you who do not usually work with IBP, or sorry, with YouTube, which I guess is not the case with young people, you can actually just search for FS-IBP. Bobby, this thing shows on the screen now, né? FS-IBP. And then after you search, you get this part here. And when you click there, you get this. And here you have all the videos of IBP. In other words, today's video will be here, plus, well, basically everyone since last year. So go through them, download for maths, maths lit, physical science, technical science. All of that is available for you. And the hint I want to give you, download the video and play it back at a little bit of a faster speed. I always look at my videos at 1.3, so all the apps can actually play faster. And if you put it on about 1.3 or 1.4 speed, it's a little bit faster, you go through the stuff quicker, and you save a lot of time by that. Okay, Bobby, now I've given them a good hint. Nah. Good. We are busy with question 2.2. The issue is we must calculate the mass of that object there. All right, so I'm going to keep this nearby because this is the way we think through our process, and I will now do it here. Okay, now you can start where you like, but based on this argument, I think it's a good way, or a good starting point would be to determine the normal force, because if we know the normal force, we can get to the frictional force as well. The big thing here is you must remember we are now going to work in the vertical plane. So for the vertical plane, the body B doesn't go into the surface, it doesn't go up, so the net force in the vertical plane is equal to 0. Now, what are the forces in the vertical plane for this one? It is the normal force and weight and the vertical component of F. So it is F plus, it's a capital F, né? Plus, yeah, by the way, it's the vertical one, plus W, small w, plus, what is the other one? N, and that is equal to 0. This is very important. And remember, F net is still equal to MA, but you don't need to write that. Or you can say F net is equal to MA and somewhere 0, because it doesn't go up, it doesn't go down, it is stationary. So A is 0, and that is why F net is 0. So this part is not actually necessary. You need to indicate that the net force in the vertical plane is 0. Now, direction. Let's choose upward positive. And I'm going to try and save time with the next question by just showing you the memo, but I need you to look through this very careful. Okay, now the vertical plane. How do we calculate this one? Now, without wasting a lot of time, to calculate the vertical component of F, the cosine of 10 degrees is equal to the vertical component of F divided by the hypotenuse, in other words, F itself, which is 60 Newton. So we can probably write this down quickly by saying it is 60 multiplied by the sine of 10 degrees. Okay, everybody happy with that? The sine of 10 is this divided by F. F is this one. F is this one. So F vertical is F times sine of 10, which is 60 sine of 10. But this one is upwards, so it must be positive. Plus W, that's my operator. Once again, listen how I talk. What is the mass of this object? It is M. Now it's basically very stupid that I write it down now like this. Let me write it for you here. The mass, you know Mos, W is M times G. Now the mass is M, and the gravitational acceleration is 9,8. Né? It's 9,8, but 9,8 is downwards, therefore it should have a negative there. So it is actually M times negative 9,8. So we can write it like this. Apologies, I have changed my mind. Let's keep it like this for the sake of showing you the right way of doing these things. Okay, so mass times 9,8. So therefore, weight will be downwards because it's negative. Plus n. Now the algebra will show us what n is. And that will be equal to 0. Everybody happy with that? Now, okay, this needs to be simplified now. Né? So you have n, and that will now be equal to. Now, this is now a bit funny because I don't have my pocket calculator with me. The sign of 10 multiplied by 60 is about 10, something. And on this side of the equal to sign, it's positive, so we subtract it here and we subtract it on that side. So it will be minus 10,4189. And this is negative 9,8 m. So you subtract this side, you subtract that. Or actually, you add it this side, you add it that side, and then you get 9,8 m minus 10,418. I just want to get my pocket calculator, Bobby. I don't know. The broadcast is going on, but it's fine. If I can just get my pocket calculator quickly, I just want to check that specific number. I can't remember where I put my pocket calculator. My apologies, learners, but I have found it. I have found it. Okay, let's come back to this one. I just want to check this number. Sine of 10 is equal to that multiplied by 60. Yeah, it's 10,4188. So it's 10,4188 something, so make it 10,4189. Okay, let's just check. So this is positive, so on that side it's negative. This is negative here, so on the other side it's positive. And remember, all of this now is Newton. It looks strange if you put a capital N there with an N here, but that is the magnitude of your normal force. So let's come back to the scheme. So we have done this part, we have done that part, we have done this part now. So now we can calculate the frictional force. The frictional force will now be easy. So let's change now to the horizontal plane. The horizontal plane. And in the horizontal plane, F net is not equal to 0 because it tells us that it accelerates to the leftmost. Né? We have this piece of info, it accelerates to the left. So I can't say F net is equal to 0 as I've done there. What are the components for F net? In this case, it is FH plus T plus F plus T plus the friction, and that is equal to M times A. But remember now, FH plus T plus that thing multiplied by N is then equal to MA. So there I've written the same thing in 3 ways. Okay, now we are going to substitute numbers. Now the block M moves to the left, so let's take to the left as positive and substitute the numbers. Now FH is the adjacent side of this triangle, so it's the cosine of 10. So it will be 60 multiplied by the cosine of 10 degrees. 60 multiplied by the cosine of 10, being to the left must be positive. So this whole number is positive. That one is my operator. Aha, now we come to T. Now we come to T. Remember, in 2.2.1 we have calculated T. But that was the T there. So the T there must have a negative number because it's in the opposite direction. So it's minus 3,2994. Happy with that? Plus now, that value is 0,3. It is given to us here. And multiplied by N. And N is this part here. And that whole thing is actually positive. This whole thing is positive because it's upwards. So it will be 9,8 times m minus 10,418. Now I'm there, and this all is equal to m, and the m is the mass of this object, so I have to use that m because that m is also capital. It's the same thing. Some learners don't do that, and then they think there are two variables. Multiplied by the acceleration, which is 2,89, and it is to the left, so we use a positive there. Okay, let me just check. F horizontal, tension in the opposite direction, and then we have this thing, 0,398 m, and that one and that one. Okay, now I thought of simplifying for you, but it's really going to consume our time. So let me just help you. This part becomes negative. Then this one and that one, it's about 10 multiplied by 0,3. Now 10 times 3 is 30. Divide by 10, it's about 3. So you will have about 3 m positive. And then this one will be there was something that bothered me because I haven't multiplied it out. There's something that bothered me. Remember, the frictional force is in the opposite direction. I almost made this mistake. The frictional force is in the opposite direction. So it must be a negative here. It's a negative 0,3 times that. So can we just make sure that all of you know this? My gut feeling said to me there's something problematic here. Remember, n is this part here. That's n. But n multiplied by the 0,3 gives the frictional force. And the frictional force is to the right. And we have chosen to the left as positive. So this whole part here, that one is positive, this one is positive, but the whole thing is negative because it's in the opposite direction. So you will get this one minus this. Then this part is negative almost 3 because that's almost 10 divided by 3 multiplied by 3 divided by 10. So this will be about 3m, but minus, and the negative times the negative give you a positive. So 10 times 0,3 will also be about 3. So you can simplify this, and then this one is 2,89m. Then all you do is you put all your m's on one side and all your numbers on the other side, and then eventually you get a mass of 10,105 kilogram. For sake of time, I don't want to simplify now. And this one, if you round it off to 10,11 kilogram, it's also fine. Now in the memo, let's just go to the memo that I can show you something there. This is now question 2.2.2. In the memo, they like to put everything in one line because it makes marking for the teachers easier. But if you take left as positive, this is the one I have done now. There you can see the negative. And if you take to the right as positive, then please remember all these things just change signs. So you can choose what you like, and I don't have time now because this morning I have showed you if you take this and that as positive and negative, you change the signs. But up to that point, you have achieved the majority of your marks. Can you see? And this is the point I want to make. For the formula, in this case, there was no mark allocated. The reason being is for the same formula in physical sciences, a mark is only allocated once in a question. So for question 2, the F net equals MA mark was already allocated in 2.2.1. So it's not allocated to 2.2.2. And that is why there are so many marks for the substitution step. But you can see it looks the same as mine, 60 cos 10 plus negative 3,2 whatever minus the 0,3, there it is, and the 9,8 m and the 60 sine 10. Now the 60 sine 10 is that one there. Okay, so lots of marks in the substitution. Challenging question, really challenging, but not undoable. And what you need to pay attention to is the fact, keep your directions in mind, think about the steps you follow to calculate that. Make sure that you draw your arrows, etc., etc., and practice enough and keep a fair head and concentration. Look how easily I skipped that sign. And if that sign is wrong, if I have used the positive there, I would not have obtained this answer. So that is a trademark of physics. You need to focus continuously. And that maybe gives me the opportunity to talk about sleep, for example. Your brain cannot function if you are tired. So before an examination, I've made that mistake in my life. I think many people do that. You think you study longer so that you can be bright, know the stuff the following morning. But in physical sciences, if you are tired and you can't think properly, to some extent it gives more problems than solutions. You need to be able to focus when you do these calculations. Okay, so I think we are covered with this one then. And the mass of the object is then 10 something kilogram. You can always go back, and I don't have time to do that now, but what you can do is you can take M and put it back into the equation. You know, take all the forces with M and calculate MA and calculate the net force. And if those two are equal, then you know this one is correct. So what I mean is, to test your answer, you can calculate the net forces on the object, and you can calculate MA, because now you know 10,11 is the mass of this object. So 10,11 times 2,89 give you something. And then you take all these forces, you have these forces, put them in here. And if these two are equal, then it means this one is correct. And that is a way to test your answer. If they are close to each other, it's still fine. But if they differ a lot, then you must know there's something wrong. And it's something I want to advise. Do that in the examination. Test your answers so that you can diagnose your mistakes. Okay, question 3 is a momentum question. For technical sciences, you guys can switch on now. It's fine for technical sciences. The only difference here, it's almost like your question on the ball and the girl moving towards each other. In this case, the velocity is given in a graph. So ball P with a mass M is initially rolling eastwards. Okay, so once again, north, east, south, and west. In Afrikaans, noord, oost, suid, west. So ball P, and I'm going to draw a sketch here, ball P, this is ball P, voor die botsing, before it goes in this direction. It collides with an identical ball Q. Now the word identical means everything of ball Q is the same as P. It is the same color, the same volume, the same mass, the same density, the same material, everything is the same. So if the mass of P is M, then the mass of Q is also M, which is rolling westwards. So ball Q, that's ball Q, it's going in this direction at a velocity of 15. Please note, I don't put positive and negative in my sketches. I just put arrows. This is a nice way. I mean, it's 15 to the west. And this one is to the east. How much? How many meters per second to the east? We can check it on the graph. It's this value because it says here ball P. The graph below shows the velocity of ball P. So ball P moves to the right or to the east actually. Yeah. That's something I need to mention now. Don't talk to the right, say east, because east is not necessarily to the right. The way I sit in the studio, on my right-hand side, it's not necessarily east. East remains east, but depending how you sit, that direction could be east, or that direction could be east. So never talk about right and left in a scenario like this, where they tell you it's east and west. Keep on saying east and west. Okay. Ignore the rotation of the ball and friction, so that only means the system is isolated, and therefore you will have conservation of momentum. Now, if you look at this one here, then you see ball P has a velocity of 10, 10, 10, 10, 10, and the next moment it has a velocity of this. Now, what is that? Okay, from there to there, it's minus 10, so there are 1, 2, 3, 4, 5 blocks. So each one must be 2. So it's minus 2, minus 4, minus 6, minus 8, minus 10. So the next moment, after the collision, I think this is what happens here, the velocity of ball P is 6, but being negative now means in this direction, so it must go west. Right, and between this point, and that one, those train lines those red lines indicate the duration of the collision. Now from there to 1 is 1, 2, 3, 4. So each block represents 0.25. So there are 2 blocks. So this change in time must be equal to 0.5 seconds. That is the duration of the collision. Okay, so the only thing we don't know is the velocity of ball Q after the collision, but this is actually what they ask here. Okay, now for this one, it's quite straightforward. I'm not going to write it out for you because it takes a little bit longer. I'm just going to show you the memo so that we have time for question 4. So point number 1, impulse. Impulse, okay, once again, a definition that you need to calculate or write down correctly, by the way, so that you get all the marks. Question number 2, calculate the velocity of ball Q after the collision. The normal thing. Total momentum before collision equals total momentum after collision. So there it is. The sum of momentum before equals the sum of momentum after. Remember the balls, there's nothing mentioned that they stick together. So assume that they remain apart from each other. And the only strange thing here is the fact that we do not have the mass. But the 2 masses are the same. And it's represented by M. So you just carry on with M. Okay, look at this one. To the east is positive. In other words, they take this direction positive. Okay, then that is positive, this is negative, and that is negative. So we have the mass before. I can't put both of these things on the screen. So 10 is positive, and the other one is in the western direction. So we talk about positive 10 and negative 15. After the collision, this one is to the west, so it must have a negative 6. And then the mass of ball Q and the unknown velocity. Now you divide right through with the M, and you solve your equation, and you end up with a positive 1. And the fact that it is positive 1 there, sorry, positive 1, I can't highlight that positive only, I want to. The fact that it is positive 1, you need to interpret that. And that positive 1 means the magnitude is 1, and the positive is in the direction that I chose positive, which is east, and that's why we say east there. And on this side, when east is negative, you will end with a negative 1 in your final answer, and therefore the interpretation. Check in this case, they haven't awarded a mark for that final numerical answer, but 2 marks for the interpretation. Sometimes they put a mark there and 1 mark here. Either way, you are supposed to get these marks quite easily. Right, now we go to the next one. It is observed that kinetic energy of the system decreases by 28.8 joule. Calculate the mass of M. Now, if a collision is elastic, then we know the total kinetic energy before the collision is equal to the total kinetic energy after the collision. But in this case, they tell us that the kinetic energy of the system, in other words, the whole lot of kinetic energy, decreases. Therefore, it is valid to write the following. The total kinetic energy, I just want to write a sentence for you. The total kinetic energy before and the total kinetic energy after. If it is elastic, I can put the equal to sign there. But in this case, they tell us that the total kinetic energy decreases. In other words, the total amount before the time minus this amount is then equal to the total kinetic energy after. And that can easily be used to calculate the mass of M, because we have now just calculated this one's velocity as 1. In other words, this is 1, and it was in the direction of the east. So we have all the velocities, and in this equation we can easily substitute them. So I'm not going to write it out, I'm just going to quickly show it to you. Okay, so there we have. Why I wrote it like that is that you can see this one. Can you see there? It says the sum of the kinetic energy initial, so this is before, is equal to the final, which is after, plus energy loss. Why does this look like that? And what I've written here is like that. Well, you can change this. The total kinetic energy before, if I add 28.8 on this side and I add 28,8 on that side, I get total kinetic energy after. Now this one is the one in the memo. So the total kinetic energy after final plus the energy loss is equal to the total kinetic energy before. That's why the I says initial. So you can write it down like that if you like to, and like that. And the rest is a piece of pie. You just substitute your numbers and you carry on. There's just one thing I want to warn against. And for some other reason, these numbers are not substituted very nicely. Check. It's a typing error and it will be corrected in the final memo, but it's important for you for substitution. The 15, if you choose to the right as positive, the 15 is to the left. So that one there should be substituted as minus 15 in brackets everything squared. Although negative 15 times negative 15 is the same as positive 15 times positive 15, it's not good mathematics to substitute it as this. The 10 is fine because it's in the eastern direction. That one must be substituted as negative 15 in brackets square if east is positive. And the same for the 6. That 6 must be negative 6 in brackets everything squared. So you will eventually come up with a final answer of some kilos. Then the magnitude of the net force. Now this is really easy. Just bear in mind the magnitude of the net force of ball P. If you work with that, you just need to identify everything applicable on ball P. So it's the final velocity minus initial velocity. I mean, this is coming from the data sheet. Now, what is the mass of ball P? We've just calculated it here, so we know this part. The final velocity of ball P is the velocity after the collision, which is this one, 6 west. And the initial velocity is 10 east. And the duration of the collision, look what I wrote here. F net delta T. I was thinking of this, that part is delta P. The duration is this part here, which is 0.5. And that is why they have this one here. It's the mass. If east is positive, then it's minus 6. Minus, maybe I must write this thing because you make a lot of mistakes with these things. F net delta T. Now delta T is 0.5. The mass of this object is, we have calculated that is as 0.2. Now the final velocity. If I take to the right as positive, not the right, east. I take east positive. Then the final velocity is this one, which is 6 in the western direction. Based on this choice, it must be negative 6. Now, that minus is my operator. Now I must put in the velocity before the collision. And the velocity before the collision is 10 east. Based on this choice, it must be a positive 10 here. I keep on focusing on these signs, but that is the thing you make errors with. So it's 0.2 minus 6 minus 10. And this is minus 16 multiplied by 0.2 divided by 0.5. So you can calculate the thing further, but you can see this is minus divided by positive. So your final answer will be minus something. And that means the direction of the net force is west. And there is the solution. So it is minus 6, minus 10. Here you can just put in a negative 0.5 if you like to, and you end up with negative 6.4. This also worries me. We cannot say minus 6.4 is equal to 6.4. You should say is equal to 6.4 Newton west. Okay? Or, depending on the question, this question asked you the magnitude of the net force. So you can stop at minus 6.4 Newton, and then you can just say magnitude of F net is 6.4 Newton. That would be fine. But this minus 6.4 equal to 6.4 is not a good habit. And if they have asked you, calculate the net force. If they leave out this part, if they ask you calculate the net force, they want you to calculate the magnitude and the direction. Then this step would have been 6.4 Newton west. So please don't do this part here. It's really important. 3.4 is quite important. It is the first time this type of question has been asked in a question paper, and I think it was just absolutely amazing. Mr. Ntsiye, who set the question, really identified a big shortcut in the presentation of answers towards the end of the year, and he has done a lot of effort to ask you questions that can identify your problems. Now, look at this one here. It says, consider the initial momentum, final momentum, and change in momentum of ball P. Which one of these three represents the resultant vector? In other words, initial momentum, final momentum, and change in momentum. Initial, final, and change in momentum. Which one of these three is the resultant of the other two? Now, this is absolutely beautiful. And I thought perhaps it's good that you just refer back to this old familiar thing, because in your data sheet you have your equations of motion that come from grade 10. And look at this first one. It says their final velocity is equal to initial velocity plus the product of A delta t. So let's write this down quickly. The final velocity is equal to the initial velocity plus A delta t. So what does A delta t represent? There's another equation that says A is the change in velocity divided by the change in time. You are familiar with this. So change in velocity is A times delta t. So that part is actually change in velocity. So this makes sense. And look there, it's written down as the addition of vectors. If I have a certain velocity, let's say 2, and my velocity changes with 7, then my final velocity will be 9. Or if I have a velocity of 16 and I go slower and my velocity changes with, let's say, 10, then my final velocity will be 6. All right? So it makes sense. Now look at this one. It is more or less familiar to what you know. So you know that delta P is the same as m times final velocity minus initial velocity. Now m times final velocity is final momentum, and m times initial velocity is initial momentum. So delta P is equal to this. But this thing is not yet written as additions of vectors. So if I rearrange it slightly, I can come up with this. The final momentum is equal to the initial momentum plus the change in momentum. And it doesn't matter whether change is positive or negative, like it doesn't matter whether the change in velocity is positive or negative. If you add change in velocity to your initial velocity, you get your final velocity, and the same with this one. And there you have something very valuable. So if your initial velocity, your initial momentum, now the initial momentum of this thing was the initial momentum was the mass times that, and the final momentum was the mass times that. So you can come up with something like that. You can say, well, there is my initial momentum. That's my initial momentum, which was, the mass was 0.2 and the velocity was 10. So it's about 0.2 times 10 is about 2. And the change in momentum, we have calculated that. The change in momentum was calculated there. It's, what was the change in momentum? I have lost the change in momentum. Yeah, well, any case, the change in momentum, if it is, let's say it's 3.2, then it's something like this. So this one plus that one. So it's, as we have done in grade 11, the tail and the head, the tail and the head. So the net momentum or the resultant momentum is you connect this tail of the first vector and you connect the head of the last vector. And then you have the final momentum there. And this is actually what it was, because the final velocity is in this direction and the initial velocity was 10 and the final 6, and the one is east and the one is west, and they want to talk about the change in momentum of ball P. So here is another one of the diagrams, the vector diagrams that you can use for this question 3.4.2. So yeah, this is the part that I was looking at. The change in momentum is 16 times 0.2. And there it is. And it is the old thing, as I said this morning, for technical sciences. If you walk this distance and you walk another distance, your resultant distance is this. You connect the tail of the first vector and the head of the last vector. If you have forces, the same thing. If you have another vector like momentum, initial momentum, change in momentum, then final momentum is there. If your initial distance is that one and the second distance is that one, what is your resultant distance? You connect the tail of the first one and the head of the last one, and the arrows sit together. So that will be. Same with forces. That force and that force give you a resultant force. The same with momentum. If that is initial and this is change, then final is there. In this case, the change is slightly more than the initial, and that is why the final is in this direction. So I hope this has helped you a lot. Lovely question, and I really hope that this helps you to achieve very, very, very good marks. Bobby, can we break for 1 minute? I just want to take a sip of water, and then we do questions 4, 5, and 6. We will ask Bobby if we can borrow a few more minutes, because we are supposed to end at 4:15. Bobby, will it be fine if we just carry on a little bit, that I can just finish the whole thing? Bobby says it's perfect. Okay, let's break a minute, just a minute, and I just want to take a sip of water. Thank you. Okay, Bobby and I are ready for you. I hope everyone is ready as well. Question number 4 is not for technical sciences, because this one deals with vertical motion. Did I say, yeah, in the case of question 3, I indicated that the technical science learners can be with us. Now, the technical science learners, you can take a short break, but when we go to question number 5, you can blend in again, although you haven't done organic chemistry this term, but very soon you are going to do organic chemistry, and I mean you can look at what we are doing here, maybe just for the sake of preparing yourself. It's a section of the work where you can easily get marks, organic chemistry. Right. So, question 4, only for physical sciences. Now, we have this lovely crane here, and it's a typical question where we apply practical principles. And this is the question, I think, where lots of you really struggle towards the end. But we must also be honest. If you've struggled with the first part, then you have not mastered the techniques of applying vertical motion correctly. So here's your chance. I will do my best to help you. And believe you me, this question is going to be very helpful as you go through the rest of the year, provided that you sort out all the mistakes. Okay. A crane on a building site is lifting a pile of bricks on a wooden pallet. Now that piece of wood, you know, it's these little pine wood things that they put together with nails and so on, and then they pack stuff on top of that. And in Afrikaans, we call it a palet, or there's other words as well. Afrikaans have so many synonyms, etc., but I think it's easy to understand. And here comes the first thing, constant speed. We had a number of them in this paper. Constant speed means the pallet is moving upwards at a velocity that doesn't change. It's not going faster, it's not going slower. And obviously for a crane, it must be vertical as it goes up. Now, when the pallet is at a height of 17.2 meters, and the question's picture shows it very effectively, one of the bricks, not many, only one, falls off and hits the ground after 2.7 seconds. There's no air resistance. Now that's normal. And they have given you a graph as well, position time graph, and then they ask questions. Now let's analyze this thing a little bit. The first thing that many people don't understand, and it is almost the same as the question in which I indicated to you, how do you get something to move upwards? Previously I explained the ground with a hole in the ground and a piston shooting a marble up in the air. As this piston was moving upwards, we said the marble is moving. Now, depending on the spring force on the piston and the weight of the marble, depending on that, you will get the marble to move faster, faster, faster. Now, in that scenario, we want the marble obviously to have a high velocity when it leaves the ground. But the moment when contact is broken between the piston and the marble, then the marble becomes a free-falling body. And then only the weight is working on the marble, is acting on the marble. And then it starts to go slower, slower, slower. But because it had speed at the surface of the earth, it moves upwards. Because Newton 1 says, it will try to keep on moving unless there's a force acting on it. Now the force of weight is acting on it. Therefore it goes slower, slower, slower. Not the force of weight. The weight of the marble is acting on it, or the gravitational force is acting on it. Now we have more or less a similar scenario here. The difference is that the pallet is moving up at a constant speed, and then a brick falls off. So the moment when the brick falls off, it has an upward speed already. And at that moment, the pallet and the brick has the same speed. Okay. Now, somewhere in the question, and remember earlier today I said to you, it's always a good idea to read through the question. So you can read through the question, blah, 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 and get a good idea of what is going on. Now, somewhere in the question, and it is here, it says, assume that the speed at which the pallet moves upwards has remained constant. Now, I mean, if you have 5,000 bricks on a pallet and one falls off, that weight is not going to affect the rest. I mean, 5,000 bricks, let's say a brick is, what is the mass of a brick? It's 1.9 kilograms. So let's say it's 2 kilograms. So if you have a load of 5,000 bricks, let's make it easier. Let's say 1,000 bricks, and every one is about 2 kilograms. It's a mass of 2,000 kilograms. Multiplied by G, that's your weight. And the cable must have a similar force upwards to move it upwards, at constant speed. Now one falls off. So instead of 1,000, you have 999 now. So the weight is basically the same. So the upward force on the pallet is basically the same. But to make sure that the question is correct, we have put in this part into the question. Assume that the speed of the pallet is the same, despite the fact that the one brick fell off. Okay, so the moment when the brick falls off, this guy carries on moving upwards. But what happens with the brick itself? That moment when it falls off, it has this speed upwards. But from that moment, the only force acting on the brick is weight. And therefore, it will go up, 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 up. This will become slower. Né? The speed will become slower, and it will go, 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 and it will stop, and then it will come and turn around, and come back, come back, come back, come back, and hit Earth. So that's basically what's going to happen. It starts with the same speed as the pallet, and while it is going up, you will actually see the following. I don't have a marble here, but let's say this is a marble, and this is the pallet. So what will happen is, the brick is on the pallet. Okay, the brick is on the pallet. This is the brick, and this is the pallet. The eraser is the pallet, and the sharpener is the marble. And I'm a big supporter of Stettler products, you can see. Okay, so the brick is on the pallet, and it moves up, 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 and then the brick falls off. Okay, so at that moment, it's going to do this. The pallet goes on, and the brick will stop and come down. I hope you get it. If I have somebody that can write an animation for me, I would really appreciate that. So it goes up, slow down, stop, speeds up, and crashes into the ground. And they have given us this position time graph. So what you can see from there to there is the position of the brick above the ground, 17.2 meters, and then so this part will be 17.2 meters, and then it goes up for a while. Now the difference between these two is 2, and 4 is 6, and 17 and 2 is 19. So it goes upwards for another 2.4 meter, and from the point where it's released to the point where it stops is 0.7 seconds. Then it falls back, and remember, during the movement up and down, gravitational acceleration is the same. So it will decelerate, it will lose speed at the same rate. It will lose speed at 9.8 meters per second every second from there to there, and gain speed at 9.8 meters per second every second from there downwards. So by the time it comes there, it will have the same speed as there. In terms of velocity, the magnitude of velocity there will be the same as the velocity there, but this one will be downwards and that one will be upwards. And furthermore, at that point, it will be again 17.2 meters above the ground. That is why this point is there. So that point corresponds with that point. This one corresponds with that one. The stopping position corresponds with that one. And the crash into the ground corresponds with that one. So from that point to there will take 1.4 seconds to 2.7 seconds, which is 1.3 seconds. So you have lots of information here about delta t, and you have position and distances and so on. Okay, so let's go quickly. Why does the falling brick go up before it goes down? So without wasting of time, let us just page to that. Because of inertia, that's fine enough to say that, or it has an upward velocity, or it has an upward momentum. Any of those would be fine. Define the term free fall. Now all I want to ask here is you must go and learn the definition for free fall, and you must go and learn the definition for a projectile, because there is a difference between the two definitions. 4.3. How long does it take the brick to reach its maximum height? Now that's easy because it's this time here. Né? So from the point where it is released to the maximum height is 0.7 seconds. And this, based on my experience, will be a very, very important time. Okay, so remember now, as the brick is moving up, it takes 0.7 seconds to that point. So that means the pallet has also moved for 0.7 seconds. And then the brick comes around and goes back for 0.7 seconds. And the pellet is also moving for 0.7 seconds. And then for the time from there to there is the time that the pellet also goes up, and we're going to need that later on. Okay, now calculate the velocity with which the pile of bricks were lifted by the crane. And this is the first one that I want to write out for you. Now, I'm going to use this opportunity to fix up a few things, and I want to do it in a very detailed manner, but there's not enough time for all the details. So here and there I'm going to refer you back to the memo. A very important technique when you deal with vertical motion calculations is listing your values. Listing your values and make sure about your directions, and obviously to use your equations of motion, and all four of them are given in the question paper. So there's no need to mess that up. Okay, so the pile of bricks, you have to calculate the velocity with which it was lifted. Now, at that point where the brick leaves the pile of bricks, the velocity of the brick is the same as the velocity of the pallet or the pile of bricks. So any of that will be fine. So let's see what info we have for that. To put everything on the screen is now a little bit of a challenge. So let's say this is 4.4.1. Right, so a nice way to do this is to list your values. So it is initial velocity, final velocity, the displacement, the acceleration, and the change in time. Okay, now the velocity at which it was lifted, obviously that will be your initial velocity, né? Because if we use the brick, we know, and let me bring this down. The brick has a final velocity on top, so the final velocity of the brick is 0. And from there to there, we can take it from there. Né? We know it is 2,4. And now I'm going to show you a trick again. We know it's meter. I don't even care to write it down because this is my rough work. This displacement is upwards. That one is 0, so it doesn't have a direction. What is the acceleration while the brick is flying upwards? The magnitude is 9,8, but it is downwards. We refer to that a lot today. And the change in time is the period until it goes up there. So it's 0.7 seconds. Now, the advantage of this is the following. If you have made a mistake in this question and you get a different time there, if you use that time in here, then you will get all the marks in this question. So you can get full marks for this question, even if you don't have that one correct. Because the issue is about the scientific argument and not necessarily have the correct numbers. It's obviously better to have the correct numbers. Okay. So I use the brick info to calculate the speed of the pile of the bricks. Né? And one thing else that you must realize, if you know 3 of these 5 values, then you can calculate it with any one of the rest. So let's take this, and I will do 2 examples because otherwise I will not have time for all the others. There's all your equations. So what you can do is you can actually tick off. What do you want? You want to calculate VI. Now there's a VI. Do I have a VF? Let me put it like that. Do I have a VF? Yes. Do I have delta Y? There's no delta Y here. So A. Do I have A? Yes. Do I have delta T? Yes. So I can use this first one. This one, can I use this one? Do I have delta T? Yes. Do I have VI? No, sorry, VI is what I want. Do I have VF? Yes. Do I have delta Y? Yes. So I can use this equation. What about this equation? Will it help me? Let's see. Do I have VI? VF I mean. VF. Do I have A? Yes. Do I have delta Y? Yes. What about this one? Do I have delta Y? Yes. Do I have A? Yes. Do I have delta T? Yes. So can you see, to calculate 4.4.1, you actually have everything. You actually have everything. So I am just going to show you the first one. So I'm going to use VF equals VI plus A delta T. And what shall we take as a direction? Now let's be generous to the upward direction and take upward positive. So all you need to do is you need to put in the stuff. So the final velocity is 0. The initial velocity is what I want to have. And the algebra will show me the sign. Plus acceleration, magnitude 9,8. Direction downwards, therefore negative. Very important. How long? Delta t 0,7. And now I solve. So VI. Now check. Negative times positive is negative. So this whole thing is negative. So on the other side of the equal to sign, you add both sides. You will get a positive. And the positive is, let me quickly check the value. It's 6,86 meter per second. And what did they ask you? Calculate the velocity. So you need to indicate after you have finished your calculation, you need to say the velocity is 6,86 meters per second upwards. All right. Now, why is this important? If you have chosen down as positive, then this one would have been a positive, and that will give you a positive on this side, and then that one would have been a negative. And then you should have said 6,86 meters per second. Negative means upwards, so this part would have remained the same, but you would have ended in a negative 6,86 meters per second. Now you can do it in all sorts of different ways. Now for the sake of time, I'm not going to use these things further on, but you can use all 4 equations to calculate 4.4.1. So let's go to 4.4.2, because there's not much time left, and the organic chemistry can't be neglected. Okay, now they want to know what is the velocity of the brick when it hits the ground. So now I want you to look at this part here. So what do we want to know? We want to know the velocity there. I'm going to work on the question paper here. So this will now be our final velocity. Now learners, you can actually use so many things. I plan to show you all of them, but time is not going to allow us that. Let's say, and I just want to draw the figure here, because I don't want to draw it on that one. So let's say you take the motion from that point up, down to that point. So this is the motion that we take. Now remember, we have just learned that this velocity is 6,86. I must perhaps just discuss the question and not write it out for you, because time will catch up with us. So if you take this whole thing as one motion, that path, the question is, can you do that? Yes, you can, because for the whole motion, the acceleration is 9,8 meters per second downwards. And the initial velocity, if you regard that as initial velocity, then initial velocity is 6,86 upwards, because this is the velocity of the pile of bricks, but it is also the velocity of that specific brick. Okay, now we want to know what the final velocity is. Then this is final velocity. Now what other variables do we have? We have delta t and we have delta y. Now everything in red fits in with this path here, and as I say, I'm just going to discuss it with you, because the mathematics you are supposed to do yourself. Okay, so this is what I want to discuss or calculate. I need to know one more, because if I have 3, I can calculate everything. How long does it take from that point to that point? Now here it's very nicely shown to us. From the point you release it, it takes 0.7 seconds, and then 0.7 back, and then the rest of the time. So it takes a total of 2.7 seconds to fly the whole path. And there you have it. So now you can go to your equations and you can calculate that. Let me just erase so that I can show this to you. I would love to write it out for you, but time is going to catch up with us. Okay, so I want to know VF. Okay, so there's VF. Do I know VI? Do I know VI? Yes. Do I know acceleration? Yes. Do I know the time? Yes. So with this equation, VF, VI, A delta T, you can easily calculate that. Now I'm going to show my rough work to you. There it is. if you take upward as positive, Vf, Vi, A delta T. Vf is positive because it's upwards. It is now for this motion. Eh? Acceleration is downwards. We can just put the delta T there, downwards, and 2,7. And then you get negative 19,6 meters per second. Now check how beautiful this is. Negative 19,6 means it is downwards. So therefore you need to interpret this answer to say velocity is 19,6 downwards. After your final step, you do that interpretation. But you can also take this part. Let me put purple there. Now at that point it stops, or it has stopped. So if you take initial as 0, then it means that is the point where it stops. So if you take from that point to that point, the duration is only 2 seconds. So now your duration becomes 2 seconds. Your initial velocity becomes 0. Acceleration is the same as before. And final velocity is what we want to calculate. So I have 1, 2, 3 pieces of info, and I can calculate that. And that is the big lesson here. Your numbers must fit the same situation. If I work with this initial velocity of 0, then I just take the time needed for that part. And I can calculate it actually with the same equation. You can use so many of these equations, and I just want to refer to this one. If you use this equation, delta y, then from this point, remember it goes up and down and down. So this point is 17,2 above Earth. So the displacement, that one, is actually 17,2 meters down. Initial velocity there is 6,8, or there is 0. So if you take this equation, then from there it's 19,6 downwards. Initial is 0. Delta T is only the time from there to there, which is 2, and acceleration is 9. So I'm not going to have time to write all of that out, but I hope you can actually see that. The last is if you just take this part. The last is only if you take this part. That initial velocity will be 6,86 downwards. But now it will only fly from 1,4 seconds to 2,7, which is 1,3. So you have the duration. The final is what you want to calculate. The acceleration is the same as before. And the only thing is you fit your values in there. In the memo, there are a few typing errors which will be corrected when we put it up on the website. And I want you to look into that. Because time, Bobby, is it fine? Can we carry on a little bit? I really struggle to finish this part. Okay. Now, so you can go on. There are many options that you can look at that. I think for sake of time, let me skip the graph because I want to come to the last part. And this was the bite in the question. When the brick lands on the ground, it is in contact with the ground for 0.3 seconds and then bounces vertically upwards with a speed of 4.59. Now, just for the sake of explaining the question, my apologies, I cannot write this out for you. Remember, since the moment the brick fell off, it took 2.7 seconds, and I'm going to write it for you there. Sorry, it took 0.7 seconds up to the highest point. Then it took a further 2 seconds to come to the ground. And once it hits the ground with a certain velocity that we have now calculated. The falling brick hits the ground. So 4.4.2 gives us the velocity with which it hits the ground. And that was 19.6. So it hits the ground with a velocity of 19.6. And then it says here, it is in contact with the ground for 0.3 seconds. So it is in contact with the ground for 0.3 seconds before it goes up due to the change in momentum, and it leaves the ground with a velocity of 4.59. In other words, you have all of this. Let me just make sure that you have everything. So the brick goes up and to the ground. So the total time is 2,7 seconds, which is this part. Then it hits the ground, stays in contact with the ground for 0,3 seconds and goes up. During all of this, the pellet is moving up. So it's moving up while the brick falls, and it's still moving up while the brick bounces back. So that is the total duration of the pellet going upwards. So at some stage, it left the ground at a height of 17,2 meter. Né? So from that point, after all of this, the pellet sits somewhere here. So we can easily calculate the height above this point by saying delta y is equal to Vi delta t plus half a delta t squared. Now, it moves at constant velocity, and this is the part where I now neglect you a little bit. Remember, the pellet is moving at constant velocity, so a is 0, so this whole thing becomes 0. The initial velocity, we have that, and all this time can be put in there, and then you get the displacement of the pellet above this one here. So the total, you just take that value, add it to 17,2, and then you get the total height of the pellet. While in the meantime, the change in momentum can be used to calculate the height of the brick after the first bounce, because it leaves the ground now with a speed of 4,59. It stops, obviously. Again, it stops. In other words, the brick does this. It leaves the pellet, it goes up, it comes down, hits the ground, and jumps up a little bit. All right. So the acceleration is 9,8 negative, or not negative, downwards, and there I have three things already. So I can calculate how high it jumps that part there. So in the meantime, the pellet has moved from that point onwards there. So this part is that part, and the brick is this part, and the distance between them is this. I'm so sorry that I can't do the whole thing because I prepared it so nicely for you, but time is catching up with us. So this is the bite for these 6 marks. There's a lot of steps involved here. The memo has it nicely written out, and you can actually calculate it. Can you see there is the 2,7, the 0,3, the 0,468, etc., all of that up to the end where you have the thing. And the last one is a piece of pie. The impulse, once again, it is the final velocity, the initial velocity. It's given to you, the time is given, and you can calculate that. Okay, Bobby, I'm almost finished. Right, let's quickly go to question number 5. As I said, the physical science learners, this is important for you. Technical science can join, although you haven't done this in the term so far. Okay. Now, question 5 is a typical question that is asked for physical science learners. Very, very typical. They normally give you a table like this, and they ask you a lot of questions there. Now, for sake of time, I'm going to show you my rough work. For sake of time, I'm going to show you the rough work. Good advice, once again, is that you read through the question to see where you are going. For example, here it says, compound A is a tertiary alcohol, compound B, compound C, etc., etc. Now, something that I found that is very useful is if you draw the structures for these things. And I'm going to show it to you so that you can just have an idea. This one can obviously draw it like this, C, 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 and there's 5 of them, and then 12 hydrogens and oxygen. So you get an idea, it's an alcohol. So there it is. There it is. Remember, you must put in your H's. Né? So it's 5 and 10, 11 and 12 and O. But this is a primary alcohol because the carbon, which is connected to the hydroxyl group, is connected to one other carbon. And they tell us here that it is a tertiary alcohol. So this one is not the alcohol that we have there. And now I'm quickly going to show you my rough work. So there it is. The OH is connected to a carbon, which is connected to 3 other carbons. And this is actually the question that they ask first and foremost, define the term tertiary alcohol. So check that you know that. Write down the following for compound A, the name of its functional group. Now, learners, doesn't matter whether it's a primary alcohol or a secondary alcohol or a tertiary alcohol, the name of the functional group is important. It is a hydroxyl group, so there it is, it's a hydroxyl group. And then they ask the IOPAC name. Now on my rough work, here's my rough work. Quickly look at that, it's this one here. So the OH is connected to a carbon, and this carbon is connected to 3 others. So if I number the longest one with the lowest number near OH, I must either start here or I must start there. Okay, so I have started there. So it's 1, 2, 3. No, it's not long enough. 1, 2, 3, 4. So I have 4 carbons, so it will be a butanol, and the OH is connected to carbon number 2, and then I have this methyl group connected to carbon number 2. So write it like I have said to you earlier. So it will be a 2-methanol, and the butanol is connected to carbon number 2 as well. So it will be 2-methyl, butan 2-ol. I'm still a little bit old-fashioned. I like this type of name, but 2-butanol is accepted. I prefer this one where it's butanol, but the OH is connected to the second carbon. Okay. Then the last one is the structural formula of its chain isomer. What you need to do here is you need to check what other thing do you have with an oxygen, a single oxygen. Remember, the ketones and the ketones have 1 oxygen. The aldehydes, 1 oxygen. The alcohols, 1 oxygen. Carboxylic acids and esters have 2 oxygens with the work we have in matric. So there are various options of what do you call them? The structural isomer. Sorry, my mind is now on this. So let me show you my rough work. So there is a possibility for question 5.1.4, the structural formula of a chain isomer. Now, what is a chain isomer? It means it has the same stuff, but the chain looks different. So this is one example where you have a carbon, a carbon, a carbon, a carbon, a carbon. Can you see the difference between this and that now? This methyl group is not there anymore. It has been moved to the end of the chain. So I still have my OH on carbon number 2, but now it goes this way. And I believe this will also be a correct one, where I move the methyl instead of on carbon number 2, carbon number 3. Now sometimes you draw a structure, but be careful. If you draw a structure like this one, you can replay the video. This OH is still on carbon number 2, so it's 1, 2 now. Né? So this one and that one are the same. Now the one in the memo is this one. They have just given you this one, which is the same as this one that I have here. So just make sure you still have to have a structure with 1 oxygen. Now for compound B, the structural formula of the functional group. Now compound B, if you look at that, it's CH3CH2 COCH3. So there's definitely, if you draw it, it's CH3 CH2, a C, a O, so we need to have a double bond there, and then another CH3. So this must be a ketone. And the structural formula of its functional group will be the ketone structural formula. And here I want to show you the memo quickly. So please make sure you have to have the carbon with the 3 bonds there, and the carbon with the 3 bonds there, and the carbon in the middle of those 2 carbons with a double bond O. And the next question is, and sorry I hurry now because we need to go through this, the IOPAC name of the straight chain functional isomer. Now carbon or this compound B has 1 oxygen, so the functional or the isomer, which is a straight chain isomer, must be something else with 1 oxygen, and that will be an aldehyde, which is butanol, and in Afrikaans, remember, it's pronounced butanol. Okay, let's skip No, we are finished there. 522. 531, the general formula. What is this? Let's look at this one. Let's look at this one. It's CH3, CH. Another C, another CH. Another CH. Okay. So, and then here on carbon number 2, I have a CH2 and a CH3. So it's a CH3, a CH, a C, and a CH. Let me put that one. 1, 2, 3. So I need to have 3 there, ne? 3 and 1 is 4. And then 1, 2, 3, 4. So I am happy with that and everything is fine. Now this is an alkyne, so I need to number 1, 2. I just need to get a piece of note here. This is uncomfortable to work like this. Sorry, I'm now going extremely fast. Where's my piece of paper now? Oh no, there it is. So it is now carbon 1, carbon 2, because there you have a triple bond. So you have to number from this side. I'm busy with C. So it's C1, 3 bonds, and then C2. So it's 1, 2, if this one is 3, and 4 there, or 4 here, and another one. So the longest chain is this one. So the longest chain is a pen. It's pen, and triple bond there means it's pentyne, and the triple bond is between carbons 1 and 2, and then I have a methyl on carbon number 3. Now, being a pentyne, it is, the general formula is CnH. Oh, I was off screen. My apologies. Sorry, I was off screen. Let me come back. It's CH, triple bond C, CH, CH3, and come this way. What I said was 1 there, carbon 1, carbon 2. Carbon 3, 4 or 4. But there's another carbon here, so the longest chain is this one. So it must be pent, and being 3 there means it's pentyne, and the triple bond is between carbons 1 and 2, and the methyl group on carbon number 3. So it will be 3-methyl pentyne, and to indicate the triple bond's position, it's between carbons 1 and 2. So therefore, there's your answer. It's 3-methyl, come back here, 3-methyl, and it's pentyne, there it is, 3-methyl pentyne, and remember, your triple bond sits between carbons 1 and 2, and you take the lowest number. So it's pent 1-ine for this part, in Afrikaans, pent 1-ine vir hierdie deel, and the methyl on carbon number 3. I'm so sorry that I go so quick now. Now, question number 6. I think what we should do here, I have actually done a few nice examples for you, but organic properties, what you need to do is when you need to explain something, remember 3 things. Remember 3 things, and I put them on the board for you there, or on the camera for you there. Remember 3 things. Look at your structure, look at your intermolecular forces, and look at energy. So when you have to discuss whether something's boiling point is higher than others, you have to look at the structure. And the memo is very clear here in terms of is it a longer chain or a shorter chain? What type of bonds there are. And also, how much energy. The stronger your bonds, the more energy you need. And the weaker your bonds, the less energy you need to overcome the bonds. Don't talk about breaking of bonds, rather talk about overcoming of bonds. So let's quickly look at these 3 questions. They say the boiling points of P, Q, and R are compared. Now look at P, Q, and R. Can you see all of them are aldehydes? It's propanol, butanol, and pentanol. So all 3 are aldehydes. In other words, they have this property. They have a carbon double bond O with a H, and then from this further on this side they have carbons and so on. So if you draw them, and I would have loved to draw them for you, but time is not in our favor. But if I quickly show you my rough work, there's the rough work. There's the rough work. You have the first one, P is C double bond H, a C and a C, and a methyl there and a methyl there. Now for Q, there's only 1 methyl because the chain is longer. And for R, it's still a longer chain. So there you have the longest chain, shorter chain, in other words, more compact and even more compact. And this is the direction in which the memo will take you. Sorry, I can't discuss this now very well, but in 6.2.2 they ask you, explain why are the boiling points different and which one will be the highest and so on. So explain the structure, explain the intermolecular forces, and from that point to this point, from intermolecular forces to energy, it's always a piece of pie. The stronger your intermolecular forces, the more energy you need to overcome the bonds. Okay, so I'm sorry, but time has run out. Bobby, thank you so much. You have given us almost an hour extra, 5 minutes here, 5 minutes there. And dear learners, I have actually prepared to give you a lot of answers in terms of the organic chemistry. My apologies. Just remember these few hints I have given you. It's perhaps a good idea to remember, to summarize now, in view of the lack of discussing this very, very detailed. Point one is, these questions where you get the tables, a good idea is draw the structures and name them, because you will most probably get names and questions on those names later on. When you deal with boiling point and melting point and vapor pressure and stuff like that, think about how the structure looks, what is the effect of the intermolecular forces. Now for that you need to look back into your grade 11 work. What type of bonds are there? Now remember, between all organic compounds we have van der Waals forces. So if you have a molecule which is a dipole, then it means there are dipole-dipole forces. But molecules like hydrogen, alcohols, if you have alcohols, because of that OH part, you will have hydrogens. Carboxylic acids, remember them. They have a carbon, double bond O, and the OH. So they actually form, for every one molecule, they form 2 hydrogen bonds. One on the OH side with another carboxylic acid, and one on the O side with another carboxylic acid. So carboxylic acids form stronger hydrogen bonds than, for example, alcohols, if all other factors are the same. So maybe we have a little bit more time at another event for organic chemistry. Okay, I have discussed, let's say, 95% of these 2 tests in detail. If you can solve your problems, you will do very well. And with those words, Bobby, thank you very much. Download the videos from YouTube, look through them, practice again and again,